So now let's look at the factor theorem. This tells us that if f of h is just the remainder, so if the remainder is equal to 0, then the value x minus h is a factor of f of x. Now conversely we can say that if x minus h is a factor of f of x, then the remainder f of h must equal 0. So that, again, best seen by example, so we'll work through a little example here. So we're going to show that x plus 5 is a factor of this here. So really what we're saying is x plus 5 goes into this without any remainder. So it means whenever we work through and use our synthetic division, we should get f of h, which is the remainder, is equal to 0. So let's go ahead and we'll do this synthetic division. So we'll just draw out our little setup for synthetic division. And we take our value of x, or x is going to equal minus 5. And we pick our coefficients, so our coefficients are going to be 2, 7, minus 9 and 30. So we start off at 2, we say minus 5 times 2 is minus 10, minus 10 plus the 7 is going to be minus 3, minus 5 times minus 3 is plus 15, and minus 9 plus 15 is 6, minus 5 times 6 is minus 30, and if we add minus 30 to 30 we get a value of 0, and this here is our f of h, which is the remainder. So in this instance the f of h, which is the remainder, equals 0, therefore this x plus 5 is a factor of f of x. So this is it done out a bit more neat and tidy. So we can say here then that the remainder f of h equals 0, so that's the remainder equals 0, therefore x plus 5 is a factor of this equation here. So let's say we have this problem here, factorise this equation, 2x cubed plus 5x squared minus 28x minus 15. Now we've seen from the previous example that we had this equation here, so we just wrote it down here at the top just as a reminder. So we had this equation here, and whenever we factorised it we got x plus 5, so we showed that x plus 5 was a factor, but in doing so we were able to pull out the actual divisor as well. So if we go back to that page as a reminder, so we showed that x plus 5 was a factor because you got a value of 0, but we're able to pull out the divisor, the quotient, sorry, as well. So the quotient is going to be the 2x squared minus the 3x plus the 6. So we've seen that in a previous video. So that means that there is also will divide into this function here, the polynomial. So let's go back to the original page. So we know that there is a factor of this, and we know that this here is also a factor. So when we multiply this by this, we'll get this a polynomial here. Now looking at this polynomial, it's the same type as this one here. It's got a cube term. So it means that whenever we factorise this, what we expect to be able to get is some value x, and it'll be a number, so it'll be a plus or a minus number. So we don't know what it is, we'll just put in a number a. And then in the second bracket we're going to have potentially 3 terms as well. So we're going to have the x, in order to get this cubed there must be some factor of x squared, and there must be a factor of x and also some constant. Okay, so it's going to look like this. It's the same format as this one. But the thing to note, and the reason for writing this down like this, is that the one that we're really interested in is the final term here, the 30, because the 30 is going to be made up of, in this case, 5 times 6. So we multiply the 5 with the 6, they'll give us the 30. So that means that in this case here, this value of a must be a factor of 15, just in the same way that this value 5 is a factor of 30, meaning 5 goes into 30. So this case here we're going to have c, this value a is going to go into the value of 15. So we have to ask ourselves, what are the factors of 15? Well, what value goes into 15? Well, plus and minus 1 goes into 15. Plus and minus 3 go into 15. And plus and minus 5 go into 15. So these are the factors of this value of 15. So that means that this value a must be plus or minus 1, plus or minus 3, or plus or minus 5. Now we don't know which one it is, and all we could do in order to factorise this is to try each of them individually. And if we try and divide them using synthetic division, if it is a factor, then we should get a remainder of 0. Now we're not going to go through all of these, I'm just going to pick out the correct one, okay, so we can show that it actually gives the value, but in this instance you would have to try each of them. So let's go ahead and we'll find out what this factor here is. So this is me written it out. We'll just talk through the values. So we've got the root as a value of 3, and we've taken out the coefficients of the x cubed, so that's 2, the 5, the minus 28, and minus 15. So we start off with the 2, 3 2s are 6, and then when we add them we get 11. 3 times 11 is 33, and we add these two together we get 5. 3 times 5 is 15, add together we get 0. So we get 0, so we're able to prove that x minus 3 is a factor and also the 3 is a root. But remember, when we did that, we would have to have gone through each of the other possible factors, the plus minus 1, the plus minus 3, plus minus 5, in order to find this value, so we'd have to have tried each of them. So now we know that x minus 3 is a factor, so we can write down here that this equation here is the same as saying that x minus 3 is a factor. Now the other factor we get from these terms here, so we're going to have 2, and it will be the x squared plus 11x plus 5. So you can see here that's us now factorised this into these two. Now we can factorise this one as well, but we're not going to, we'll leave that until another video. But you can see here that we mentioned that we needed to know what the particular roots are. Now in this case they were the values of minus 3, and this was ended up plus 5. So as I've mentioned, these are best understood by examples, and we'll go ahead in the examples videos and we'll get a few of them done. So thank you for listening. I'll get you in the next video. Goodbye.